So I mentioned in other videos, I said there's a z-score and there's a t-value. These two are really similar to each other. We can use this when we're assured that the mean is approximately normally distributed. And that assurance comes from a large sample size. In this problem, we have a sample size of 21, which is below our 30 sample size cutoff. If it's above 30, you can use z. If it's below 30, you need to use t. So watch out. The formula is the same as the other questions we've been doing in the course, except now we're using t instead of z. So I'll show you a website where you can get t. But everything else is the same. So the mean is 910. The t-value, so I'll help you look this up. So I Google search percentile to t-value calculator, and danielsoper.com is actually the first one that does what I want. These other ones go in reverse. This is what you want. You want to have some sort of probability level or some sort of probability that you can type in and a degrees of freedom. And I'll show you how it works. So when you're using a t-distribution, we need an extra number in our calculator or in our table. We need degrees of freedom. All it is in our course is when you have a sample size, you just subtract it by 1. So 21 minus 1 makes 20. So our degrees of freedom is 20. If you had a sample size of 28, then you'd plug in a degrees of freedom of 27 into the calculator. And the 99% confidence, that's just like what we were doing with the z-score. If you want to have 99% in your center, then that means you want 0.5% over here and 0.5% over here. So what we're going to type into our calculator is 0.995. So we got degrees of freedom 20 and then 0.995. So wait, was it really 20? Yeah. 20 and 0.995. And then this one actually does have two-tailed, so we don't even have to do that trick. You could just type in 0.999, that would give us the right t-value. Oh, but that would be for the tails. Sorry. So what this calculator is doing, since that's a really low value, right? It's calculating the probability level in the... I'd have to think about that. That looks like it's to the right. Oh man, this is doing right tail. That's confusing for students. But if you use this website, all you need to know is that the value you want to take is the positive value of this right-tailed value. Normally tables do left-tailed values, so that's a bit confusing. So 2.8453, that's the t-value that we're going to want to use. I think our textbook would round to say it's 2.85 though. I think it rounds to the second decimal place. I'll check my answer though. So that's our t. The sample standard deviation, that's just like sigma, except it comes from the sample. They tell us for this one it's 20. So this is plus or minus. It kind of went downhill here. So times 20. And then we divide by the square root of the sample size. And so the calculation is just like what we were doing on the other questions. It's easiest to do the square root of the square root first. Copy that to your clipboard. So Control C for me, Command C for Apple computers. And I'm doing 20 divided by that pasted value, the denominator. I multiply that by 2.85. So this is our margin of error. So we're doing 910 plus or minus at 12.483. Okay, so our two values for this confidence interval, just a reminder, you do this once for minus. They say 3 decimal places, so I'm going to round this one up to 2. Get this out of the way. And then once for plus. So to 3 decimal places, that would be 922. Those are the two values of the confidence interval. You'll do the same exact thing, same t-value even, in part B, except you're going to change this 20 to a 40 and then repeat the calculations. And same thing for part C, except you're plugging in 80 for the standard deviation. Everything else should be the same.